Hello. Um, this video is going to be on how to do the MPV frequency evaluation. We've already done our sales growth as a random number, our sales price is a random variable, variable cost is random, overheads as a percentage is a random variable, our weighted average cost of capital is random. So first step for me, at least the way I did it, was to calculate my unit sales. This is the base units, and I multiply it by 1 plus the sales growth in the first column, and then go ahead and fill down. For everything else, it's going to relate back to whatever my initial starting point was. So it's just whatever was before times 1 plus the sales growth on that sheet. And you can see that as we go out, we just picked a different sales growth associated with it, and we're always referring back to the sales that were right before. That gives me all my sales numbers. In terms of calculating the benefit, I'm taking this unit sales times the sales price, which is random for each period, minus unit sales times variable cost, which is random, minus unit sales times sales price times the random overhead value. And I'm subtracting from that the same quantity, and then I'm also subtracting from it, or multiplying by wrong thing. I'm multiplying it by just the tax rate. Now, one thing that I didn't do here was, well, I also took the straight line depreciation out of it as well. So this becomes basically my value, the benefits that's coming based on my kind of made up sample here. In terms of calculating the NPV, now that I have my cash flow stream that's coming in, slide over here to my NPV, my investment, I just arbitrarily said it was $2 million. It's our NPV value. You'll notice it's we're going to pick the WACC that's a random variable. We're going to the benefit tab for what my positive cash flows are. And then we're going to subtract the net present value of the investment, which is right up here. Now I'm doing a single investment. You're responsible for doing the capacity balanced investment scheme. So you're going to have some up front, and then after year 5 and year 6, you're going to have a negative cash flow associated with the increase in plant capacity. So once I have this particular number here and that equation, I'll just fill down, right? So it'd be to like K, whatever, or to be, I don't know, 2 or 4. Highlight and then use the fill command to fill down. So that's just the process that you go through. That gives me my list of NPVs. This happens to be a grossly positive project. Here's my min value for it. This is the average value, and this is the maximum NPV value. And this represents the standard deviation of this column. The range is simply max minus min, and then the step, I'm just dividing by 25 because I'm in 25 boxes here, actually 26. To set the minimum one, I just set it equal to the minimum plus my count number times what the step is. Start at 0, go forward. Drag it down, and then on the upside, you don't necessarily have to add that 100 there. You want to make sure that your sum is going to be actually your 200 events, so that there's a box for everything. So this one is equal to or less than between these two, between these two, etc. Cumulative probability here is we're just going to keep a running sum. You notice the first term is $sign, the second one isn't, and we're going to divide it by our 200. So this is just what's known as a cumulative probability function. Obviously at the end we're going to have 100%. It's going to be 200 divided by 200. Over here we're using the normal probability distribution. So in that case, we're taking the value of MPV, we're plugging it into with the average, the standard deviation, and 1 for cumulative, and dragging that down. So this is what we're going to use to form our downside risk curve. I've done the MPV one. It'd be nice to see an IRR one as well, but I'm not requiring it. And then we just chart it. So what we're going to do is plot two terms. The green line, the blue line here is the cumulative probability one. The red line represents the normal probability distribution. And in my instance, they're always positive. So there's a 50% probability right here. And probably the cumulative, if you had 10,000 observations as opposed to 200, the cumulative distribution is almost like surely going to run right on top of the normal. But with 200, you can see there's obvious deviations between them. And this just give you an idea of, what's the probability, for example, of being under 900,000. Well, you come over here to 900,000, you go up and across and say it's, about 5% probability of being under 900 value. There's almost a zero probability of being a negative MPV project based on all these different things. There's also say a 70% probability that the MPV of the project is going to be, there's a 30% probability, 70% minus 70% of the MPV project being over about 1.5 million. So, that's the way I would like to see the interpretations. Your valuations and everything are going to be a little bit different. You may always run with a positive MPV project based on the different distributions that you selected, but not necessarily always. Remember, we fixed that price so that you had the center of it was a positive MPV in year 0. In year 6. It has a 0 MPV, and the low end was you had MPV pricing at 0 MPV in year 10. So that's the basic process that you're going to go through. I want it nice and neatly formatted, and I'm leaving the table up to you that's going to compare your nominal values to your Monte Carlo simulation. Give you an idea where everything and how the Monte Carlo simulation works. All right, thank you very much. This is the last project, so good luck.